Hey everyone, and welcome to another deep dive. Today we're going to tackle something pretty massive, pretty complex, and pretty crucial to, well, life as we know it.
We're talking about climate change.
Yeah, but not just the headlines and the doom and gloom. We're going deep, cosmic deep even.
Think beyond the usual talking points. We're going to look at climate change from a planetary perspective.
So we're not just talking about Earth, are we?
Not at all. We'll be visiting our celestial neighbors, Venus and Mars, to see what their climate stories can teach us.
I love that. So kind of a comparative planetology approach to understanding climate change.
Exactly. By comparing Earth to other planets, we can gain a broader perspective on the forces that shape climate, the timescales involved, and the potential consequences of unchecked change.
Okay, so we're going on an interplanetary road trip. What kind of luggage are we packing for this deep dive? What sources are we pulling from?
Well, we've got a whole stack of fascinating research. We're looking at scientific papers, historical records, even data from space probes exploring other planets.
Wow. Okay, so we're going deep into the science. But I gotta ask, why should our listeners care about what happened on Venus or Mars millions, even billions of years ago?
Because these planets offer valuable lessons about how climate can go right and how it can go very, very wrong. They're like natural experiments playing out across the solar system.
Okay, I'm intrigued. But before we blast off to other planets, let's ground ourselves here on Earth for a moment. Can we define what we mean by climate and how it differs from weather?
Sure. Weather is what you experience day to day. It's the sunshine, the rain, the wind. Climate is the long-term average of weather patterns over years, decades, even centuries.
So weather is like the mood swings of the atmosphere, and climate is the overall personality.
That's a great way to put it. And just like our personalities, Earth's climate has changed dramatically throughout its history. To understand these changes, we need to grasp the concept of climate forcings.
Climate forcings.
These are factors that can nudge a planet's climate in one direction or another, either warming it up or cooling it down.
Okay, so kind of like the dials on a giant thermostat controlling Earth's temperature.
Exactly. Some forcings are natural, like volcanic eruptions that spew ash and gases into the atmosphere, blocking sunlight and leading to cooling.
Oh, right, like that massive eruption of Mount Tambora in 1815 that caused the year without a summer.
Exactly. That's a dramatic example of a natural climate forcing. But there are other, more subtle forcings at play as well. Things like variations in solar output from the sun itself, wobbles in Earth's orbit, and even impacts from asteroids or comets.
Wow, so our planet's climate is influenced by factors both near and far, from the heart of our planet to the depths of space.
Absolutely. It's a complex interplay of forces, and to really understand it, we need to broaden our perspective, which is why we're taking this interplanetary deep dive.
Okay, let's blast off. First stop, Venus. It's often called Earth's evil twin, right? Why is that?
Well, despite being similar in size and composition to Earth, Venus is a scorching hellscape. Its surface temperature is hot enough to melt lead.
Yikes. I guess no sunscreen is strong enough for that kind of heat. What went wrong on Venus?
A runaway greenhouse effect. Venus has a thick atmosphere, almost entirely carbon dioxide. This CO2 traps heat like a blanket, turning Venus into a giant oven.
So greenhouse gases, which we often hear about in the context of climate change on Earth, are they inherently bad?
Not necessarily. In fact, greenhouse gases are essential for life as we know it. They trap some of the sun's heat, keeping Earth warm enough to support life.
Okay, so it's kind of like Goldilocks and the Three Bears. Too much greenhouse effect and you get a scorching Venus. Too little and you get
You get Mars, our next stop on this interplanetary tour.
Mars, the red planet, the once and maybe future home for humans. It's pretty cold and dry today, right?
It is. Mars is a frigid desert with an incredibly thin atmosphere. It's lost most of its atmosphere to space over billions of years, thanks in part to a weak magnetic field that doesn't protect it well from the solar wind.
Solar wind, what's that?
It's a constant stream of charged particles from the sun that can strip away a planet's atmosphere if it's not adequately protected.
Ah, so it's like a cosmic sandblaster, slowly eroding Mars's atmosphere over time.
Exactly. And without a thick atmosphere to trap heat and hold on to water vapor, Mars transformed from a potentially habitable world into the barren landscape we see today.
So Venus teaches us about the dangers of a runaway greenhouse effect, and Mars shows us the importance of a protective atmosphere. It seems like Earth is sitting in a pretty sweet spot, right?
For now, yes. We have a Goldilocks climate, not too hot, not too cold, thanks to a balance of greenhouse gases and a strong magnetic field. But as we're learning, that balance can be disrupted.
Right, and that brings us back to Earth and the challenges we face with climate change. We've seen what can happen on other planets.
Hmm.
Now it's time to delve deeper into our own planet's history.
Exactly. Let's rewind the clock. Way back to Earth's early days, billions of years ago. Back then, our sun was much fainter than it is today.
A fainter sun. Shouldn't that have made Earth a giant snowball?
You'd think so, wouldn't you? But here's the paradox. Evidence suggests that early Earth was warm enough to support liquid water, despite the weaker sun.
Okay, now you've got me really curious. How do we explain that?
Well, scientists believe that Earth's early atmosphere was much thicker and richer in greenhouse gases like methane and carbon dioxide.
So even billions of years ago, the greenhouse effect was playing a key role in shaping Earth's climate. It seems like a fundamental process that's been operating throughout our planet's history.
Absolutely. But here's where things get even more interesting. As life evolved, particularly photosynthetic organisms, they started pumping oxygen into the atmosphere.
Ah, so the rise of oxygen, which we need to breathe, actually changed the composition of Earth's atmosphere.
Exactly. And over time, this led to a decrease in the concentration of those potent greenhouse gases, methane and CO2, and the development of the more moderate greenhouse effect we have today.
So life itself played a role in shaping Earth's climate.
Absolutely. It's a fascinating example of how interconnected Earth systems are. The atmosphere, the biosphere, the geosphere, they all influence each other over time. And that brings us to one of the most intriguing and dramatic chapters in Earth's climate history. Snowball Earth.
Snowball Earth. It sounds pretty chilly.
It was. Imagine a planet almost entirely encased in ice, from the poles to the equator.
Whoa. That's like something out of a science fiction novel. Did this actually happen?
Multiple times. And scientists are still piecing together the exact causes. One leading theory suggests that a drop in atmospheric CO2, possibly due to increased weathering of rocks or volcanic activity, could have triggered a runaway cooling effect.
A runaway cooling effect. You mean like a positive feedback loop where cooling leads to more cooling?
Precisely. As ice sheets expand, they reflect more sunlight back into space, which further cools the planet and causes more ice to form. It's like a snowball rolling downhill, getting bigger and bigger.
So how did Earth escape these deep freezes? Did someone just crank up the global thermostat?
Well, it wasn't quite that simple, but volcanic activity likely played a key role. As volcanoes continued to erupt, they released CO2 into the atmosphere, slowly building up the greenhouse effect and eventually thawing the planet out.
So even in the face of extreme climate shifts, Earth has an amazing ability to self-regulate and find a new equilibrium.
Indeed. But the key takeaway here is that Earth's climate history is punctuated by periods of both stability and dramatic change. And while the events we've discussed occurred over vast timescales, they provide valuable insights into how our planet responds to changes in atmospheric composition, solar radiation, and other key factors.
It's like studying the blueprints of our planet, understanding how all the systems interact and influence each other.
Exactly. And that understanding is crucial as we grapple with the current climate crisis. By learning from the past, we can better prepare for the future.
Well, this has been an incredible journey so far. We've traveled from Venus to Mars, back to Earth's early days, and even endured a few Snowball Earth episodes. And we've learned that climate change is a complex, dynamic process that's been shaping planets for billions of years. But we're not done yet.
Next time, we'll delve into the age of dinosaurs, exploring a time when Earth was a hothouse, with tropical forests stretching nearly to the poles.
Ooh, I can't wait. And we'll uncover how this ancient warming event, along with other key events in Earth's history, hold clues to understanding the challenges we face today and the potential solutions that lie ahead.
Stay tuned. Welcome back, everyone. Last time, we journeyed to some pretty extreme places, didn't we?
Yeah, from the scorching surface of Venus to the frigid deserts of Mars. Talk about a cosmic climate roller coaster. But we learned a lot about how planetary conditions can affect climate.
Exactly. And those lessons from Venus and Mars can help us understand the delicate balance that makes life on Earth possible.
Right. And we also took a trip back in time to Earth's early days, exploring the faint young sun paradox and those crazy snowball Earth events.
It's fascinating to see how Earth's climate has changed over billions of years. But today, we're going to fast forward a bit to a time when giants roamed the Earth.
Giants. Are we talking about a real-life Jack and the Beanstalk situation?
Not quite. We're talking about dinosaurs and the time period known as the Jurassic Heat Wave.
Okay, I'm picturing a stegosaurus wearing sunglasses and sipping a giant margarita. Was it really that hot?
Imagine a world with no polar ice caps and sea levels significantly higher than today. That's the Jurassic Heat Wave.
Wow, a real prehistoric heat wave. What caused this intense warmth?
Well, several factors were at play. Higher levels of carbon dioxide in the atmosphere, for one. Volcanic activity was pumping out massive amounts of CO2, and the breakup of supercontinents probably released a lot of carbon as well.
So Earth was essentially a giant sauna for dinosaurs.
Pretty much. And this intense warmth had a profound impact on the evolution of life during that time. Think gigantic herbivores like the Brachiosaurus, who munched on the lush vegetation that thrived in this warmer, wetter world.
It's amazing how climate change can shape the evolution of species. But did this Jurassic heat wave eventually cool down?
It did, but it wasn't a smooth transition. As the Jurassic period gave way to the Cretaceous, Earth's climate started to cool, leading to changes in plant life and some extinctions.
Ah, so even gradual climate changes can have ripple effects throughout ecosystems. It's a reminder that life on Earth is constantly adapting to a changing environment.
Absolutely. And speaking of adapting to change, there's another dramatic climate event from Earth's past that I think is particularly relevant today. It's called the Paleocene-Eocene Thermal Maximum, or PTM for short.
PTM, okay, you're going to have to break that one down for me.
Around 56 million years ago, Earth experienced a sudden and intense warming spike. Global temperatures jumped by 5 to 8 degrees Celsius in just a few thousand years.
Whoa, that's like turning up the global thermostat on it. Fast forward, what caused this rapid warming?
Scientists believe it was a massive release of carbon into the atmosphere. We're not exactly sure where all that carbon came from, but possibilities include volcanic eruptions or the destabilization of methane hydrates on the ocean floor.
Methane hydrates. Those are those icy deposits of methane trapped under the ocean, right?
Exactly. And if they destabilize, they can release huge amounts of methane into the atmosphere, which is a potent greenhouse gas.
So the PTM is basically a case study in rapid climate change driven by a surge in greenhouse gases. Sounds eerily familiar, doesn't it?
It does. And the impacts of the PTM were significant. Widespread extinctions, especially in the oceans. Acidification of the oceans, changes in rainfall patterns, and some species even migrated towards the poles in search of cooler habitats.
It's like a glimpse into a potential future if we don't address climate change.
The PTM serves as a warning from the past, reminding us that Earth's climate system is sensitive to changes in greenhouse gas concentrations. And that brings us to the present and the role that humans are playing in shaping Earth's climate.
Okay, let's talk about the human factor. We haven't been around for billions of years, but we're certainly making our presence felt.
We are. Human activities, particularly since the Industrial Revolution, have become a dominant force shaping Earth's climate. We've become a force of nature, altering the planet on a scale comparable to major geological events.
So we're not just passive observers anymore. We're active participants in shaping Earth's future.
Precisely. And that means we have a responsibility to understand how our actions are affecting the planet. One of the most significant ways we're impacting the climate is through our use of fossil fuels.
Right, those carbon-rich fuels like coal, oil, and natural gas that power our industries and transportation systems.
Exactly. Burning those fossil fuels releases carbon dioxide into the atmosphere, and CO2, as we know, is a greenhouse gas. It's like we're wrapping Earth in a thicker and thicker blanket, trapping more and more heat.
And deforestation adds another layer to this problem, right?
Yeah.
Cutting down trees removes a vital carbon sink, a natural way to absorb CO2 from the atmosphere.
Exactly. Trees act like giant air filters, absorbing CO2 as they grow. When we cut down forests, we're not only releasing the carbon stored in those trees, we're also reducing our planet's ability to absorb CO2 from the atmosphere.
This is like a double whammy. More carbon going into the atmosphere and less capacity to remove it. Not a good combination.
Not at all. And let's not forget about agriculture, which also plays a role in climate change. Certain agricultural practices, like raising livestock and using synthetic fertilizers, release methane and nitrous oxide.
And those are even more potent greenhouse gases than CO2, right?
They are. So as we strive to feed a growing population, we need to find ways to make agriculture more sustainable and climate-friendly.
It seems like we're facing a complex web of interconnected issues contributing to climate change. But there's a common thread running through all of this, isn't there?
I think so. What do you have in mind?
It's carbon. From volcanic eruptions to the decay of organic matter to the burning of fossil fuels, carbon seems to be at the heart of many major climate shifts throughout Earth's history.
You're absolutely right. Carbon is a fundamental element for life, but it also plays a key role in regulating Earth's temperature. The amount of carbon in the atmosphere, oceans, and land is in constant flux, and those fluxes influence the greenhouse effect.
So understanding the carbon cycle and how we've disrupted it is crucial for addressing climate change.
It is. But here's where things get even more complex and I think even more fascinating. We've talked a lot about how changes in Earth's atmosphere can drive climate shifts. But there are other factors at play as well, things like Earth's albedo.
Albedo. That rings a bell. It's about reflectivity, right? How much sunlight a surface reflects back into space.
Exactly. Light-colored surfaces, like ice and snow, have high albedo, meaning they reflect a lot of sunlight back into space, which helps keep the planet cool. Darker surfaces, like oceans and forests, absorb more sunlight, leading to warming.
So, as ice caps melt due to global warming, Earth's albedo decreases, leading to even more warming and further ice melt. It's another one of those positive feedback loops, right?
It is. And it's not just ice. Deforestation also reduces Earth's albedo by replacing light-reflecting forests with darker croplands or urban areas. It's like we're painting the planet a darker shade, making it absorb more and more heat.
It's amazing and kind of scary how interconnected all of these systems are.
Yeah.
One change can trigger a cascade of effects throughout the entire planet.
Exactly. And that's where predicting future climate change is so challenging. Earth's climate is an incredibly complex system with countless interacting variables.
It's not like trying to predict the outcome of a game with a million players, each with their own strategies and motivations.
A very apt analogy. And that's where climate models come in. These sophisticated computer programs use mathematical equations to simulate Earth's climate system, helping us understand how different factors interact and project potential future scenarios.
So it's like running a giant simulation of Earth's climate to see how different choices might play out.
Precisely. But of course, there's always a degree of uncertainty involved, especially when we're talking about projections decades or centuries into the future.
Right. We can't predict the future with perfect accuracy. But can climate models still give us valuable insights?
They can. Climate models have consistently shown that human activities are driving global warming, and the consequences are likely to be significant if we don't change course.
Okay, so we have a warning. Now, what about solutions? Where do we go from here?
That's a great question, and it's the focus of our next part. We'll explore the innovative solutions being developed and implemented around the world, from renewable energy to sustainable agriculture to policy changes aimed at curbing emissions.
So, while we've uncovered some pretty weighty topics today, it's not all doom and gloom. There's hope, there's innovation, and there's a growing global movement pushing for change.
Stay tuned for the final part of our deep dive where we'll explore the path forward together.
Well, here we are, the final leg of our climate change deep dive.
It's been quite a journey, hasn't it? From the fiery depths of Venus to the icy plains of Mars, all the way back to Earth's tumultuous past.
We've really dug deep into the science, the history, the complexities of this planetary phenomenon, haven't we?
We have. And we've seen that climate change is not just a modern-day issue. It's a process that has shaped the very evolution of our planet and countless others.
Exactly. And while the challenges we face today can feel overwhelming, I think it's important to remember that we're not powerless.
Absolutely. We have agency, we have ingenuity, and we have a growing global movement working towards solutions. That's what we'll be exploring in this final part. The paths forward, the glimmers of hope, the ways we can navigate this challenge and create a more sustainable future.
So let's talk solutions. What are some of the most promising avenues for tackling climate change? I think a lot of folks are looking for a sense of hope, a sense of direction.
Well, I'd say one of the most exciting and rapidly evolving areas is renewable energy. Harnessing the power of nature, the sun, the wind, the tides, even the heat beneath our feet.
Renewable energies like switching from a gas-guzzling clunker to a sleek electric vehicle, right? A cleaner, more efficient way to power our world.
That's a great analogy. And the technology is advancing all the time, becoming more affordable and accessible. Think solar panels, blanketing rooftops, turning sunlight into electricity. Think wind farms dotting coastlines and plains, harnessing the power of the breeze.
It's like we're tapping into the planet's natural energy flows, working with nature instead of against it.
Precisely. And as these technologies mature, we're seeing a global shift away from fossil fuels, a transition that is gaining momentum every day.
And it's not just about large-scale energy production, is it? Individuals are playing a role too. More and more people are installing solar panels on their homes, driving electric cars, making conscious choices about their energy consumption.
Absolutely. It's about empowering people to become part of the solution, to take ownership of their energy choices, and contribute to a more sustainable future.
It's a collective effort, a global movement.
It is. And speaking of collective efforts, we can't forget about the importance of transportation. Cars, trucks, planes, they all contribute to greenhouse gas emissions. But innovations are happening here, too.
Absolutely. Electric vehicles are becoming increasingly popular and affordable. And for longer journeys, there's high-speed rail, a much more energy-efficient alternative to air travel.
It's about rethinking how we move, how we connect, how we design our cities and transportation systems for a more sustainable future.
It's not just about technology, though, is it? It's also about changing mindsets, shifting our values.
You're right. It's about recognizing that our well-being is inextricably linked to the well-being of our planet. It's about consuming less, wasting less, appreciating more.
It's about shifting from a culture of excess to a culture of sustainability, right?
Exactly. A culture that values experiences over possessions. A culture that understands the interconnectedness of all life on Earth.
And this is where I think policy plays a critical role, doesn't it? Governments can create incentives, set regulations, invest in research and development to accelerate the transition to a more sustainable world.
Absolutely. Policies can help level the playing field, making sustainable choices more accessible and affordable for everyone. Think carbon taxes, renewable energy subsidies, investments in public transportation.
It's about creating a framework that supports a sustainable future, a future where economic growth and environmental protection go hand in hand.
And it's not just about national policies. International cooperation is crucial too. Agreements like the Paris Climate Accord bring countries together to set targets for reducing emissions and collaborate on solutions.
It's a reminder that climate change is a global challenge that requires a global response, a shared commitment to protecting our planet for future generations. But I know policy changes can be slow and often face resistance. It can be frustrating.
It can. But there's a growing movement pushing for change. People around the world are raising their voices, demanding action from their leaders.
And it's not just activists and scientists, it's businesses, investors, communities, even faith-based organizations. It's a diverse coalition of people who recognize the urgency of this challenge.
And one of the most inspiring aspects of this movement is the youth climate movement. Young people are stepping up, demanding a better future, and they're not afraid to hold those in power accountable.
They give me so much hope. They're not waiting for permission, they're creating change themselves. And they're reminding us that we all have a role to play.
Exactly. Every action matters, whether it's reducing our own carbon footprint, supporting sustainable businesses, or advocating for policy changes. We can all be part of the solution.
Well, that brings our climate change deep dive to a close. It's been a whirlwind tour of planets, time periods, scientific discoveries, and, most importantly, human ingenuity and resilience.
We've seen the challenges, we've explored the complexities, and we've glimpsed the possibilities. And what have we learned?
We've learned that climate change is not just a problem to be solved. It's an opportunity to reimagine our relationship with the planet, to create a more just and sustainable world for all.
And that's a journey we must take together.
Now we want to hear from you, our listeners. What resonated with you most during this deep dive? What questions are still swirling in your mind? What actions are you inspired to take? Share your thoughts, your hopes, your ideas. Let's continue this conversation because together we can create a future where humanity and nature thrive in harmony.